Today on How It's Made. Fiberglass boats, clothes dryers, bubblegum, and fireworks. They're sleek, they're fast, and they're fun. Fiberglass boats can jump waves and turn on a dime. The fiberglass body is low maintenance and durable, so these watercraft don't deteriorate the way wooden boats can. A computerized saw cuts out the wood pieces they'll use to build the mold for the fiberglass boat. It takes a team of artisans about 15 months to design and build the mold. They first construct the frame. Then they build up the shape out of fiberglass. The mold must be perfect in order to cast a boat that's free of faults and defects, so they painstakingly work on the mold's finish in particular, coating it in a special high-resistance paint that will withstand about 8 years of castings. Once they've finished the mold, they can begin casting the fiberglass boat. The equipment feeds just the right ratio of fiberglass to plastic resin. Fiberglass is glass in the form of very fine, flexible fibers. They may look fragile, but those fibers are stronger than steel. And they won't burn, stretch, or rot, so they make perfect boat building material. Workers make sure they roll the fiberglass into every nook and cranny. This is critical because if they don't apply the fiberglass thoroughly, the boat will have structural defects. As heat within the fiberglass builds up, it hardens. Next, they roll on a material called roving. It reinforces the fiberglass and makes it more rigid. They also install wood at the spots where they'll later mount equipment. They coat the wood with fiberglass to protect it from moisture. After about an hour, it's time to extract the casting from the mold. They use a lever system to lift out the hull. They cut out holes for the mechanics. Then they install the boat's deck. They install the motor and the electrical wiring for the mechanics and plumbing. The boat truly takes shape in the final assembly. They put together the upper part of the boat, called the shell, and the inside, called the liner. They install the furniture, then certain components by hand, such as the dashboard. Last stop, quality control. A series of tests to ensure that all the mechanics function well and that the boat is absolutely watertight. Finally, a protective wrapping to protect the boat during shipping.
next week.
We have pulled out all the stops.
Cool!
The most up-to-date and incredible stories as Daily Planet celebrates 10 years of discoveries.
Happy anniversary, Discovery.
Pretty cool, huh?
Then,
Out of this world.
Jesse takes the crew out to meet the monsters where they live.
Cool.
As Monster Monday revs up.
Just the wrongness of it is what makes it good.
Daily Planet, followed by Monster Monday, next week.
Electric cars are cheaper to run than gasoline-powered cars. Just plug them in to recharge. No fill-up required. But they cost 40% more to buy, which offsets the savings. Battery technology will have to improve and come down in price before electric cars can truly take off. Clothes dryers were invented in Europe in the early 1800s. The lady of the house would put the clothes in a metal barrel with holes in it, then turn it by hand over the fire. The first electric dryers were invented around 1915. Most of the parts are made from steel, just 3/4 of a millimeter thick. The factory receives it from the supplier in giant rolls. They go onto a machine that cuts sheets about a meter long. Using those sheets, industrial presses stamp out various dryer parts. These are motor supports. And this is the back panel of the drum, the rotating compartment that holds the clothes. Note those small holes. We'll come back to them shortly. To form the side of the drum, the machine bends a sheet of pre-painted steel into a circular shape. When a clothes dryer operates, it sucks in outside air through a hole at the front. The air passes through the heating element and goes into the drum, entering through those little holes you saw a few moments ago in the back panel. Once the automated machines have finished shaping the drum, they form a groove on its outside surface. This groove is for the motorized belt that drives the drum. Next, they put the drum on another machine that screws 3 baffles in place. Baffles are those thick plastic wings located inside the drum. They're what throw the clothes around as it rotates. Back on the automated line, the drum's front rim goes on. They manually assemble the drum's back panel. Then a machine installs it. Next comes the exhaust duct. Hot, moist air exits the drum through a bunch of holes and a large slot in the dryer door. The air gets channeled downward through the lint screen, then goes through a duct at the front of the dryer to the fan. The fan blows the air out this exhaust duct at the back of the dryer. The dryer's heating element works much like the element in a toaster, except it consumes a lot more power, up to 6,000 watts. The factory receives the steel and ceramic heating coils ready-made. Workers simply position them on a sheet of galvanized steel. They also install a temperature sensor that shuts off power should something go wrong and cause the dryer to overheat. In the finishing department, they coat the dryer with powdered paint that's heat and shock resistant. Then they assemble the bottom and back of the appliance. They install the motor that drives both the belt and the fan. Then the exhaust duct goes in. Automated machines prepare the electrical wiring. They paint and cut the wires, Then install a terminal on each end. Workers wire the dryers, then install the drum. They close up the sides, screw on the door, then wire up the control panel. It's connected to a series of gears and switches that control the dryer cycles. The model and serial number sticker marks the last stop on the assembly line. Chewing gum dates back to the ancient Greeks who chewed resin from trees. Modern chewing gum was patented in the U.S. in 1869 by, believe it or not, a dentist. In 1928, another American invented bubble gum. Bubble gum comes in gumballs of all colors and sizes. But for blowing bubbles, nothing beats the chewy, gooey pink stuff in the twist wrap. It all starts with a gum base, the stuff that makes gum chewy. Traditionally, the base came from tree resin. Today, it's synthetic, made of plastics and rubbers. They pour the gum base into a mixer. Then add color and flavoring. As it begins mixing, they pour in glucose syrup, a sweetener. Because it's liquid, it helps keep the gum base soft. Next, they add dextrose, a powdered sweetener. They blend the ingredients for about 20 minutes. The stirring action builds up heat, which melts everything together. The mixture's ready when it reaches the consistency of bread dough. They transfer it by cart to a machine called the pre-extruder. The machine squeezes the mixture through a narrow opening, like squeezing toothpaste from the tube. This transforms the big, bulky wad into thin, manageable strips that can then go through the extruders. The extruders squeeze each strip down to the actual width of a piece of bubble gum. It comes out as one long, continuous stream to be cut into bite-sized pieces later on. This extrusion process heats up the gum. If they were to cut and wrap it now, it would stick to the wrapper. So the next stop is a cooling chamber. The gum goes in for 15 minutes at between 3 to 7 degrees Celsius. When the bubble gum comes out, it's cooled down enough for what they call the cut and wrap. One machine does both jobs in a fraction of a second. Watch the action in slow motion. As the continuous stream of gum enters on one end, the machine cuts it into bite-sized pieces, pushes each piece into a wax paper wrapper, then twists both ends of the wrapper closed. Here's the slow motion replay from a different angle. The machine processes 900 pieces of bubble gum per minute. Last stop, packaging. The bubblegum moves on to a scale that automatically weighs out the right amount per tub. They seal the tub with plastic to make it airtight. This keeps the bubblegum fresh. Ever wonder why bubblegum is pink? It's because that's the only color Walter Deemer had on hand when he invented this treat back in 1928. Since then, the color just stuck. What's a holiday celebration without fireworks? Brilliant colors exploding in the air, the oohs and ahs they elicit on the ground. Fireworks are so high-tech these days, it's easy to forget they're not a modern invention. Historians believe gunpowder, the explosive ingredient in fireworks, was invented in China around 1000 AD. It's said that in a famous battle, the Chinese emperor illuminated the sky with it, scaring away the enemy. During the Renaissance, the Europeans invented the type of fireworks we know today. Modern pyrotechnicians use computers to ignite fireworks from a safe distance and to synchronize their bursts with music. Assembling explosives into fireworks is the job of the pyrotechnician. Even the tiniest spark of static electricity could set them off, so anti-static gloves are a must. A firework is made up of separate compartments within a shell. The burning fuse explodes one compartment at a time, creating those staggered bursts in the sky. The pyrotechnician first glues the main fuse into the bottom of the shell. The glue is naturally colorless. It's dyed blue so he can tell exactly where he's applying it. He puts the bottom aside to work on the second compartment of this two-compartment firework. He starts by spooning a powdered explosive into the center. Then he caps it. Here he's working on two fireworks at a time. Next step, a brown cardboard shock absorber to shield this compartment from the first compartment explosion. Then a corrugated cardboard disc and a plastic spacer. It'll take the fuse 1.5 seconds to burn through these two components, creating a slight delay between the first explosion and the second. Gluing the second compartment together is tricky. If it's too tight, it'll stifle the explosion, but it has to be tight enough to withstand the delay. With the second compartment done, it's time to prepare the first. He glues a sleeve onto a case, then fills it with hundreds of stars. Stars are what create the flashes of color. They're carefully measured explosives mixed with coloring agents, such as magnesium for white, copper salts for blue, charcoal for orange. The pyrotechnician must handle them gingerly, or they could detonate. Next, he adds comets, another type of exploding decoration. He tops it off with gunpowder. Finally, he glues the two compartments together, filling the remaining space with the same combination of ingredients. Once the shell is full, he glues on the cover, and the tighter, the better. The more pressure that builds up, the bigger and more spectacular the explosion. Next, he wraps the firework in craft paper. The label uses international color codes to indicate the size of the shell. The lift charge, a gunpowder bag with a long, fast-action fuse, goes at the base of the shell. That's what'll send the firework into the sky. When they light the main fuse at the top, it simultaneously lights two secondary fuses. The time delay fuse running inside the shell through the compartments of explosives, and that long fuse running along the outside down to the lift charge at the base. Once the lift charge ignites, heat and gas build up inside the launch tube until they explode, propelling the firework up to 300 meters skyward. Let the light show begin. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.